polynomials here. You have ax to the n power. So your n is 3, your a is 1. So what this is saying is the 1 goes there for a, and the 3 goes there for n. So it's 1x to the third. So that is what x to the third looks like. Now if I go back and make that an x to the, okay, let's make it x to the second. Well, 1x to the second is a parabola. So can you see a parabola there? So if we go over, okay, that would be a third power. Okay, see how it kind of goes through 0 right here with a twist? All right, let's go 1 over. Fourth, do you see how it looks kind of like a parabola? Fifth, do you see it kind of looks like the third power, it goes through with a twist? Sixth, like a parabola again. Seventh, through with a twist. 8, bounces off like a parabola. Do you see a pattern? 9, goes through with a twist. And 10, like a parabola. So what you hopefully noticed with, if you look at the even powers, do you see how every even power, that's a 6, 4, 2, kind of bounces off. And you also see how it bounces off, it gets thicker and thicker. Look right here. See how it gets flatter and flatter? There's a reason for that. But it does bounce off on evens. If you look at odds, so 3, 5, 7, 9 are all twists off. Now what would a 1 look like? Well, 1 would be a line because x to the first is just x. So it's a line, but it goes straight through. So that goes straight through, but it still goes through right there. Alrighty, so let's put that back in to a, let's go to a cube. Alright, so at a cube. Now let's change a. What is a going to do to the graph? Well, a, the number in front, tends to vertically stretch and shrink it. So watch what happens as I pull it to the side. Do you see how I get bigger and bigger and bigger? See how it's stretching up, getting steeper kind of? And then as I shrink, do you see how it's vertically shrinking, flatter, flatter, flatter? Keeps getting flatter, flatter, it's getting flat. Oh, see how flat? It's almost aligned, flattens out, and then it flips. Oh, so a negative will flip it upside down. So negatives seem like they flip it upside down. Negative a value. Oh, interesting. So would the power still be affected the same way? So if you look at this, would the fourth power still flip, just upside down? So it's a fifth bounce, it goes through with a twist. 6 bounces, but it's on the bottom. Now do you notice on the odd powers, you see how it starts up and ends down now? Okay. If it's a negative a value, it goes downward. All right, and then the evens go like this and end down, so they're upside down. Everything basically gets flipped upside down. So let's look at a different graph now. I'm going to take this back to a cubic. Let me take this back. Let's go over to 1 here. And I'm going to get rid of this graph and look at this graph, this red one right here. This red one's a little bit different because I have x plus 1 and x minus 2. And the x minus 2 has a power, and the a still affects it, how it would. All right, so here's the graph. Look at this. My x-intercept, also called my 0, is at negative 1. Look at this number here. If I take negative 1, what's negative 1 plus 1? Doesn't that give you 0? So wouldn't that be a 0 or an x-intercept? Here at 2, if you look at that, that is an x-intercept because what's 2 minus 2? 0. It creates a 0. So at 2 creates a 0 and at negative 1 creates a 0. And that will always hold. We'll talk a little bit more about that later. Let's see if a still affects things. Remember a does a vertical stretch and shrink, so watch what happens. Do you see how a, you can really see the stretch a lot better here. Do you see the hump down here getting smaller? Okay, and if you see this, see, oh, smaller, 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 flip, and then stretching it again. So you can see the a really showing its flare with this red graph. Okay, hopefully you notice that the x-intercepts did not change when you changed a, the number in front. All right, let's see what happens when you change the power of the last piece. Now the power only goes to this minus 2. So the minus 2 is this positive 2x intercept. So this guy's going to stay the same the whole time. Now do you notice this one goes through without twisting or anything? That's just straight through because it has a 1 power. If it has a 1 power, it just has a nice straight through. See right here, right now, n is a third power. So if n is a third power, it should go through and twist like we talked about. So what if n was a squared? Well, do you see how this stays? But do you see how it bounces off now? See how it bounces off because it's even. So let's take it all the way to a 4th power. Well, it bounces off again. All right, what's the 5th power going to do? Well, it should go through with a twist. Oh, there it is, through with a twist. Okay, so what is a sixth? Bounce off at 2, then it's going to go through with a twist. You see the same pattern happens every single time. It's just staying at 2. Where earlier when we did this graph, it was at 0. But my 0 here is 2, because that's what we're powering. We're powering the x minus 2. So as I go back, you still see the even powers bounce off at 2. Okay, so let's go back to the fourth there. And if we change a, watch what happens again. Just stretches vertically, shrinks vertically, flips upside down. Now just remember, if you have a negative a value, it always goes down on this side. It's always going to go down on this side. Because watch, see how it's going down here? It's always going to go down on a negative a value. On this side, it flips back and changes. Watch what happens. So I'm going to change in. See what happens here? See how this is still going down over here, but it changes back and forth. So every time I do this, the right side's flipping back and forth, but the left side keeps flipping. This side over here keeps changing, but this side always stays down. It's kind of interesting. So the right side tells us how it's going to end. So if it's negative, it's always going to be going down. If you change this to a positive value, so I change that to a positive, it's going up. And if I change this, the left side changes up, down, up, down, up, down. And if you always notice, it's always going straight through here, but what happens when you change the end value is it only changes that value, how it goes through that value. So what does a power on a 0 give you? It tells you how it's going to go through that 0. Is it going to bounce? It's even. If it's going to go through with a twist, odds. If it evens will bounce, through with a twist are odd. Every time. The only difference is if you make it a 1, it goes through. You can't see it very good there. But if you make that power a 1, see the 1, do you see how it goes through straight? Same as this is the 1 right here. So they're both straight through, this creating a parabola. So that's the only one. The only odd number that does not twist is a 1. Now, do you notice we don't do negative powers? Negative powers completely change everything. We're only doing positive integer powers with what's going on here. So that's really important. It has to be integer and it has to be positive. Okay, so let's also look a little bit at what would happen if we change these numbers right here. So let's say I change this to a minus 3. Oh, minus 3. Do you see how my x-intercept is all of a sudden right there? What if I change that to a minus 1? My x-intercept all of a sudden is right here. See, this guy stays the same every time. All right, so it's always, this depicts where that's going to be. All right, so if I do a minus 4, you see it right there on the edge, boom. So we can change that to whatever we want. Let's go back to 2. It just changes and shows you where your x-intercept is going to be. Again, we did not affect this. Now if I put a power on this one, it would be twisting and bouncing, but we were just affecting this particular 0 right here and showing the twists and the bounces. So if we go back to this one, it can tell you the basic polynomial would be this one. It's the third power. A is also 3. You see how it goes through with a twist. Squared is bounce off. You can see the bounces and twists every single time. With the positive a value, remember it goes up. If it has a negative a value, remember the right side always goes down. You'll get the hang of this just with practicing it more and more. It helps. This is Desmos. If you get on Desmos and play with it, make up your own equations. See how it affects everything. Just remember, the number opposite of this is your 0. The number in front, which I call it a, affects it by vertically stretching and shrinking it and possibly flipping. And the power, remember the power, if there's a power, a 1 like this goes straight through. Okay, and what else would, let's see, a fourth power right here, good. Even bounces. Odds, show you an odd. Twist through. The only one that doesn't twist through that's odd is 1. 1 goes straight through. Good luck with all this. Hopefully this video can help you.